Good morning. Uh, this is the last mini video that you're going to see for week two's material. Um, we're going to be talking about homework six today, and then there's also the Zoom lecture that'll take place later this morning. So homework six, let me show it to you on Connect Math. Notice there's a quiz number two that's coming up starting early as tomorrow, and then you have until Sunday to complete it. Let me preview the assignment here. Before I preview the assignment, I want to talk about what we're going to be doing today. So basically, there's three situations. Okay, there's three situations when you graph two lines. Okay, when we graph two lines, so I'm gonna draw three different coordinate planes here. Okay, because there's some vocabulary that you have to get used to. Um, when you graph two lines, let me just choose blue to graph the lines. Um, the two lines can intersect, means they can cross. Right? They can cross at a particular point. Um, the two lines can be parallel. Okay, they can be parallel, meaning that they have the same slope. Um, but what else could happen if we graph two lines? They could cross. They could be parallel. What else could happen? Um, the other thing that could happen is you could actually have a line that's actually graphed right on top of the line that's already there. So I'm going to put like a double arrow right here. Okay. So there's three situations. Three situations. They cross at one point. They never cross because they're parallel, or they cross everywhere on the line. So that'd be like they cross in infinite number of points. And so there's some words or vocabulary that you need to be used to. Um, if uh, if two lines are graphed and they have one or more solution, one or more solutions. Now, a solution is where they cross. So, like that one has one solution, that one has zero solutions, and this one has infinitely many solutions. But if a system of equations, basically that's what we're talking about. If they have one or more solutions, it's called consistent. Okay, so this one is consistent, and this one is consistent. I'm just going to abbreviate it consistent with CONS. Um, and this one here does not cross at all. So this one has zero solutions, and so this one's called inconsistent. Okay, inconsistent. And it's either one or the other. It's either going to be consistent or it's going to be inconsistent. So there's only one example here, or one type of system that's going to be inconsistent. Now the other word is dependent or independent. Um, if two lines are different, they are independent. So this one is independent because those two lines are different. Okay, independent. These two lines are different, so these are called independent. These two lines are the same. These are the same. So they're the same. So these are the opposite of independent is dependent. Okay. So two lines cross, different lines, consistent and independent. Two lines are parallel, inconsistent, and independent. Two lines are the same, consistent, and dependent. So you might want to pause the video and write that down in your notes, because the first few problems will ask you whether systems are consistent or inconsistent, and then also ask you whether they're independent or dependent. Okay, so I'm going to go ahead and clear the screen here, and I'm going to start the assignment. Okay, so question 1 says the graph of a system of linear equations is given. So notice how we see two equations. We see two equations, but I only see one line. And that's done on purpose, because that line must be the line for both of the equations. So both the equations are that same line there that you see. So if that is the same line, then we say that this is consistent. And let me check my answer here. This always gets in the way. Check my answer. So I said consistent because it's the same line, and then they're also dependent. And we have to check our answer each time. Okay. Now, how many solutions are there? If we only have one line, we say that the system has infinitely many solutions. Infinitely many solutions. And we check our answer. Okay. So you're not asked to really do any solving. And that's going to be the same for problems 1 through 6. So 1 through 6, go back to your notes, and you'll have 3 parts: part 1, part 2, part 3. Okay. If the two lines cross, it's going to have one solution for part 3. If the two lines are parallel, they'll have no solutions. And if you only see one line, it's going to have infinitely many solutions. All right. The majority of the work in homework 6 is going to be starting on problem. It's going to be starting on problem 7. So problem 7 actually has you solve a system of equations without graphing. Okay, and there's a couple different methods that are used. One's called the substitution method. And so I want to go over this today, and I'll be going over this in Zoom this morning as well. So the substitution method, it's called the substitution method because what you're going to be doing is you're going to be, well, let's look at what we have. We have two equations. And we're asked to solve for x and y. The first one is the x. The second one is the y. So what we do is we substitute what we know one of the variables is equal to. So this one here is written in a form that we know y is equal to 2x minus 5. So if y is equal to 2x minus 5, that means that this y right here is equal to 2x minus 5. So we can't solve an equation for a variable if we have two different variables in the equation. So what we're going to do is we're going to substitute. That's why it's named the substitution method. We're going to substitute 2x minus 5 in for this y right here in that top equation. So I'm going to rewrite that top equation. X plus 7 times, notice I'm using parentheses because I have to multiply the 7 times the 2x minus 5. So I want to put that 2x minus 5 in parentheses. And that equals 10. Now I have one equation. I have only x in that equation, and so I should be able to solve an equation for that variable. So I have to use the distributive property. Okay, so this is going to be x plus 14x minus 35 equals 10. Okay, so let's see. This is a 1x. So 1x plus 14x. I can combine those two. That's 15x. I can go ahead and move that 35 over to the other side. If I add 35 to both sides, I get 45. Okay, so I'm combining a couple steps here. So hopefully you're with me here. I'm not showing every step. And then I divide both sides by 15, and 45 divided by 15, that's nice. It's a whole number. I like it when the answers turn out to be whole numbers. That way we don't have to plug in any fractions. All right, so that's not your entire answer, but you've done more than half of the work though. You've gotten the x value, right? The x value is 3. The x value is 3. Now we have to find the y value. Well, let's look at our equation here. What equation is going to give you the y value? Well, both equations will give you the y value. The bottom equation will give you the y value quicker, right? The bottom equation will give you the y value quicker because the bottom equation is solved for y. So now all we do is we just plug in 3 for x right there, because we know x is equal to 3. So 2 times 3 is 6, and 6 minus 5 is equal to 1. So we got the x, we got the y, we just plug it in, we plug the 3 in, we plug the 1 in. If we really wanted to make sure that this was the solution, we could plug in 3 for x and 1 for y in both the equations, because that point is the point that these two lines intersect. They intersect at point 3, 1. Okay, we can go ahead and check our answer, and it'll give us the green check mark. Substitution method. Substitution method is from 7 through 14. Those are all substitution method problems. Okay, so you're going to get a lot of practice using the substitution method. One variable has to be solved for to use the substitution method. If one variable is not solved for, you have to solve for a variable. So let me show you what I mean. Erase this here. Okay, let me show you what I mean here. Let's see, question 8, one variables. Okay, so like here, question 8. You have a variable solved for. Here, x is equal to 7y plus 5. So you can plug in 7y plus 5 in for this x. So the substitution now is going to go this way. This 7y plus 5 is going to be plugged in for this x value. And then you're going to go ahead and solve for the variable. You're going to solve for y. Okay, I'm not going to do this problem, but that's kind of the way you'd go about the substitution method. You look to see which variable is solved for. What's that mean, solved for? Solved for means it's by itself. The variable is by itself. If the variable is by itself, it is solved for. Okay. I'm sure we're going to get to one that the variable is not solved for. Like this one here. This one here, there's no variable that's by itself. There's no variable that is solved for. So before you use, this is number 9. I don't know whether your problem number 9 is going to be the same as my problem number 9. Probably not, because Connect Math kind of randomizes the problems. But if a variable is not solved for, you can't use the substitution method. you have to solve for a variable first. Well, let's see. What variable would be easier to solve for? X or Y? The variable by itself is easier to solve for. So I'm going to, in this equation, x minus 4y equals 12, I'm going to simply add 4y to both sides, and I'm going to make this 12 plus 4y. And now I have a variable solved for. And now I can plug in 12 plus 4y in for this x right here. Just make sure you use parentheses because you have to distribute the negative 4. Okay, and I'm not going to solve that one, but that's the beginning of that problem. Okay, I will be going over more problems like this in the Zoom lecture later this morning. Okay, 7 through 14 all deal with the substitution method. Okay, so starting on 15, there's a new method. It's called the addition method. I think you're really going to like the addition method. I think there's a good chance that you're going to love the addition method after you do 7 through 14. After you do those 8 problems or 7 problems, you're gonna want to find a different method. Okay, some of them get a little bit tricky with the fractions. The addition method is a pretty slick method here. What this one has is it has all these variables and equal signs and numbers. They're all lined up. Okay, they're all lined up. Like when you line up decimals, if you have to take 1.6 and you have to add like 0.2, you want to make sure your decimals are lined up. It's kind of the same thing. You want to line up. You want to line up so your x's are above your x's, your y's are above your y's, your equal signs are above your equal signs, and your numbers are above your numbers. Because then what you can do, it's called the addition method for this reason, is you can just simply add the equations together. You could add equations to other equations. I know, mind blowing that you can add equations to other equations. But you can. Look, 1 plus 2 equals 3. 3 plus 4 equals 7. You could add equations vertically. 3 plus 1 is 4. 4 plus 2 is 6. 7 plus 3 is 10. 4 plus 6 equals 10. That's kind of what we're going to do here. We're going to add these equations together. Now, look what happens. 4x plus a negative 4x, the x's cancel. The x's cancel. That's a great thing. The x's cancel because then, let's see, you have negative 3y plus 6y. That's 3y. And negative 13 plus 10, that's negative 3. Well, if your variable cancels and you have 3y equals negative 3, then you can just solve for y. Y is equal to negative 1. You still have to find out what x is. But once you get a variable solved for, like we got y is equal to negative 1, now we have a choice. We can plug negative 1 into the first equation, or we can plug negative 1 into the second equation. We have to plug it in for y. Okay, so I'll just use the first equation. 4x minus 3 times negative 1 is a plus 3 equals negative 13. 4x minus 3 times minus 1 is positive 3 equals negative 13. Now I just solve for x. 4x equals let's see, -3, subtract 3, subtract 3, so that's -16. That's nice because it doesn't turn out to be a fraction. X is equal to -4. So once x is -4, we go to here. We can just click this. We put -4 in here, and we plug in -1 here. And we check our answer. Okay, so that one is it's basically set up for you to use the addition method. Are all problems set up for you to use the addition method? It'd be nice if they were, but they aren't. We have to do a little bit of rearranging in some of the problems. So like this one here, it's not really set up to use the addition method. It just says solve the system. It says the system has no solution, the system has one solution, the system has infinitely many solutions. Well, this one here, it is lined up. Okay, it is lined up. It's lined up. It doesn't say solve the system by addition method, but I'm going to use the addition method because they're lined up. I don't really want to graph both these, and I really don't want to solve for x or y. But it is lined up. But it's just they don't. If I add the equations together, right now, there's nothing that's going to cancel. Okay, it's not like the last problem. Okay, the last problem. I think I can go back to the last problem. Yeah, the last problem. See how you have the 4x and the -4x, and they cancel. In this problem, the 2x and the -10x aren't going to cancel. The 4 and the y aren't going to cancel. The 8 and the 142. Well, you don't need the numbers to cancel. You need the variables to cancel. And so what we can do is we could actually do something we've never been able to do in problems before. We could actually change the numbers so that we have something that cancels. Okay, I know that's kind of weird. You can actually change numbers. But you can. Okay, you can actually change numbers as long as you understand that you have to multiply. Okay, you have to multiply to change numbers, and you have to multiply each part of the equation by the same number. So, like, I would really like in this problem here, I would really like this 2x to be a 10x, because if that was a 10x, it would cancel with the -10x. So in this equation right here, I can make that 2 a 10 if I multiply by 5. So I'm going to multiply every term of that equation by a 5. And I'm just going to write it over here. Okay? I'm going to write a new equation over here. So this is going to be 10 x plus 20 y equals 8. Okay, 10x plus 20y equals 8. Actually, sorry, not 8, but I'm glad I made that mistake because I only put the 5 on that side. I want to put the 5 on this side too to remind myself that I have to multiply by 5 on both sides. Okay, so if you only put the 5 on that side, you might only multiply by 5 there. So that 8 becomes a 40. Okay, so it's very consistent. Okay, you have to be fair. You have to multiply every number by the same number. And I chose 5 for a specific reason. I chose 5 because I saw that -10 underneath the 2x. Okay, so now I could add these equations together. 10x and -10x cancel. 20y and 6y is 26y. 142 and 40 is 182. Okay. And again, I got those equations by adding the bottom equation by this new equation that I made from the top equation. Okay, so now I want to divide both sides by 26. Hopefully this turns out to be a whole number. I'm going to use my calculator right now on my cell phone that's in my pocket. So I'm going to take 182 and I'm going to divide by 26. And I get 7. Okay, so I know that y is equal to 7. Y is equal to 7. Well, if y is equal to 7, I still have to find out what x is. I have two equations. The top equation is easier than the bottom. Actually, I have 3 equations. If you count this one, I got 3 equations. So I can plug it into this one. I could plug it into this one. I could plug it into this one. I'll just plug it into this one I circled because it just has some. I know the numbers are a little bit bigger, but they're pretty easy to multiply by. If I plug 7 in for y right there, this is 20 times 7, so that's 140. So I get 10x plus 140 equals 40. That's 10x equals 40 minus 140 is negative 100. And so I know that x is equal to negative 10. Okay, so let's see. If I plug in, the system has no solution. No, system has one solution. The system has one solution, so I'm going to click this. And then I believe it's going to allow me to... okay, I click inside this first, and then I click that, which it gives me the 2 boxes, and I got to put in the negative 10 first, and then I put in the 7. And then check my answer. Okay. All right. So those questions 15 through 20 are going to deal with solving systems by the addition method. Tomorrow, I'm going to put a little mini video on about the solutions to systems that have infinitely many solutions or no solutions, and you can tell without looking at the graph. But I want to keep these videos relatively short, so I'm going to stop here and stay tuned tomorrow. I'll put something on Canvas early in the morning before our Zoom. Thursday's Zoom is kind of optional as far as your attendance. I don't usually record them, so you might want to make sure to view the Zoom meeting today, which is Wednesday. All right, bye for now.